All right, so now we're going to talk about how to graph the square root function. First, we're going to talk about the parent function, which is simply the square root of x. So we already talked about, if you have a problem like this, a square root function, we know that the domain of this function would have to be x is greater than or equal to 0. The range we'll say in a second here. If we were to plug in some key points into this function and simply just make a table of values, let's just do that. So here are some key points with this graph. First of all, what can I plug in for x? I'm going off of my domain. I can't go below 0. I'm going to start with the first point that my domain allows, which is 0. So if I plug in 0, my output is 0. If I were to plug in, again, 1, the square root of 1 is 1. And, you could plug in 2. The square root of 2 is a decimal. Same thing with 3. So why don't we plug in 4, because we know that the square root of 4 is going to be 2, and so forth. The square root of 9 is 3. So there are some points that we can simply graph: 0, 0, 1, 1, 4, 2, and 9, 3. So this graph cannot go to the left, right? It can't go left. It has to start at 0 and go to the right. So my graph goes like this. All right, so when we think about the range is all the y values that we are graphing. So you can see from the graph, we're graphing everything from 0, and we're graphing everything up. So the range we're going to put here as well is y, or in this case, f of x, is also just greater than or equal to 0. So for the parent function, we have our domain and range, we have some of our key points, and we have what our graph looks like there. So let's talk about some translations. All right, so now that we know what the parent function looks like, let's look at a translated and transformed graph. So here's a square root function with 3 different parameters here, a, h, and k, which is going to be very similar to looking at any other function and seeing the same effects. So we'll just call this a general square root function. So we want to figure out what is the a, h, and k, what type of effects do those have on the graph, and how can we use that to our advantage. So to do that, we're going to look at Desmos first. So here's Desmos, and here is the parent function, y equals the square root of x. And you can see that we have the same graph that we already had looked at. Now let's take a look at the a value. I'm going to put an a here and add a slider to that. Watch what happens if a increases. Watch what happens to the graph. It is stretched upward, right? So it's vertically stretched upward, and if I go to like a negative value, it's stretched downward. So then it's decreasing instead of increasing. So if I were to play this, there's a increasing, it stretches up, and when a decreases, it goes down like that. So if we go back to our general equation, what does the a value do? The a value is a dilation, and it is a vertical stretch, or you could think of it as a vertical compression. So vertical stretch / compression. And so there's a. And then, as we saw, if a is positive, the graph is increasing. If a is negative, the graph is decreasing. It's going downward, right? So keep that in mind. Now let's look at h. So what does h have? What effect does h have on the graph? So I'm going to take out this a, put it back to normal, and now I'm going to put an x minus h in there. I'm going to add a slider for h. Okay, so if h goes to 2, 2.4 right now. You can see it's moving to the right as h increases. The graph moves to the right. As h decreases, it moves to the left. So we have what we call a horizontal translation here. It's just moving left or right, or a slide. So that's all h is doing. So let's put that in there. H is just a horizontal shift, we'll call it, or you can call it a horizontal translation or a horizontal slide. It's just moving the graph left and right. Notice too that that value also is having a direct impact on the domain of that function that we talked about before. Okay. All right, so the last thing is k. What is k having an effect on? And so if we go here and now I take this away, let's take out the h and let's just put in the plus k, add a slider, and we animate that. You can see that k is just shifting up and down. It's just taking the parent function and translating it up or down. So pretty simple there, and that is the case for all of these different translations and transformations. It basically has the very similar effects on any function that we choose, whether it be a square root function, whether it be quadratic or linear. It doesn't really matter. These patterns always hold true. So k is just a vertical shift up or down. All right, so let's take a look at one of these general equations, and instructions here say to sketch the following square root functions using coordinate transformation from the points above. Identify the domain and range of each. Okay, so here's my function. It is the square root of x plus 5 plus 1. Now you could take this a couple different routes. You could look at this function and immediately tell me what the domain is, because we already talked about that. We know from a domain perspective that there's a restriction on this function, and that is x plus 5, the radicand, has to be greater than or equal to 0. So therefore, I know from the start that x is greater than or equal to -5. You could start right there, and that would be fine. The domain is x is greater than or equal to -5. Now, if we're going to sketch this using the points from above, so what we're talking about with these points is we're looking at this parent function right here. So let's say this is the parent function, right? And I'll put this in blue for this first one, right? So here's the parent function. This is f of x equals root x. So if I graph the parent function here, of course, it's the same. 0, 0, 1, 1, and then 4, 2. 1, 2, 3, 4, up 2. There's my parent function. But this one's different, right? So if we look to this new function, this has two translations. The h and the k value are different. So if we go and look at this, and we state what these transformations are, here's my transformations. I'm going to list them off. It's going to be a horizontal, because my h is 5 here. I'm going to have a horizontal shift 5, and this is going to go to the left. That's one transformation that I'm going to have here, and that's because I have an x plus 5 there. So I'm adding 5 directly to the x, and that provides that horizontal shift to the left here. The other thing that I'm seeing here is that I have a plus 1. And so the other shift I have here is a vertical shift. Vertical shift of 1, and that's going to be up. It's going to go up 1. Everything's going to go up 1. So what you can do here is you can, using your parent function as a guide, right? These are the key points for the parent function right here. 0, 0, 1, 1, 4, 2. I can come up with this new function here. I'll put it in green so you can distinguish. And each one of these points is going to follow these transformations here. In other words, if you take a look at this point right here, Let's look at 0, 0 right here. Well, each point is going to follow the instructions that I have here, these two transformations. So if I take this one point, I'm going to take a horizontal shift 5 to the left. Okay, so I'm going to take this point and go 5 to the left. 1, 2, 3, 4, 5. And then I have to go up 1. Boom, so there is my new point. So I'm going to keep this blue one here. I'm just going to make a copy of that. And now this new point, 1, 2, 3, 4, 5, to the left 5 and up 1. There's my new function. I'm going to put that in green just so you can see this example. So that point is following these instructions up here with my translations. It went left 5, up 1, and that point mapped to that. So if you look at the algebra, or just like the numerical change here, I went from 0, 0, and basically I subtracted 5 from the x. So this became -5. I moved the x value to the left 5. And now I'm going to take the y value and I added 1 to it. So then I take my y value, which is also 0, and I add 1 to it. Okay, so that's kind of the way to think about these critical points of the parent function, which never change. And then you can look to your transformations and translations up here with your a, h, and k, and then take those points and move them accordingly. So now, same thing with these other points. I'm going to follow the same instructions. I'm taking this point right here at 1, 1, and at 1, 1, and I'm going to do the same thing. I'm going to move left 5 and up 1. So I'm going to go 1, 2, 3, 4, 5, and up 1. And so there's that point that translated. On this right here, if we look table to table, that means I'm subtracting 5 from the x. So 1 minus 5, that is -4. And I am adding 1 to y, or shifting the y up 1. So that 1, original 1, that becomes a 2. And hence you have this point -4, 2 right there. All right, and then the last point right here, which is at our 4, 2. Okay, I could do the same instructions, move left 5, 1, 2, 3, 4, 5, and up 1, and there's that new point. If you just think about the numbers, I'm going to be subtracting 5 from 4. So 4 minus 5, that is -1. And I'm going to add 1 to my y. So this becomes a 3. So you can see I have my original function here, which is these points. And I have these new translated points that are following these instructions up here, moving left 5 and up 1. So therefore my new graph is going to be this green graph that basically looks the same thing as the blue, but it's just being moved over and shifted around a little bit. Now notice that from the get-go, we knew that the domain was x is greater than or equal to 5, which is clearly shown in the graph. That we're not graphing anything to the left of -5, we're graphing everything to the right of -5. So again, notice how this critical point, the 0, 0 point, in the beginning we realized that the domain is basically, -5, greater than or equal to -5, and that this shifting also has this same correlation with that domain. I basically shifted this thing over 5 units, and you can see how that domain and that shift kind of correlate together. The range here would be, in this case, y, actually f of x is what we're calling y, would be greater than or equal to 1. Because look at the y values that I'm graphing for the green graph. Here's where I'm starting. I'm graphing everything from here, and I'm graphing everything up. All the y values that I'm graphing, starting here, you can look at this graph, or the table of values as well. My y values start at 1, and then they just increase. If I were to keep plugging in points there, the y values would simply increase and increase and increase. So the answer here is this green graph right there. And there's several ways to get this graph. We really want you to think about the a, the h, and the k values and how that translates and shifts around the graph from the original. Let's take a look at another one here. So we have f of x equals -2 times root x minus 1 and then plus 3. So that's the function I'm trying to graph. Now, understand that I could simply plug that into my calculator, right? Like there's my function, and I can look at the table of values. There's my table of values, right? Starting at 1, and these are the points that I can graph. I can even graph this, right? I can see my graph and all that kind of stuff. What we're going to focus on here is, again, the translations. So if you look at my A, H, and K values, let's take a look at these. My H value is 1, right? So I'm just going to put H, and then my A value, my K value. The H value is 1. That means I'm going to have a horizontal shift of 1, and that's going to the right because it's x minus 1, so therefore it's going to the right 1. The A value is -2, so I have a dilation of -2. That just means that I am stretching out the y values by -2, and I'm multiplying the y value by -2. The K value is 3, and that's a vertical shift. Vertical shift of 3, and that's going up in this case. So how do we graph this? We really want you to think about these patterns. So we think about the parent function, right? We have the parent function, which is simply 0, 0, 1, 1, 4, 2, if I'm just thinking about the square root of x function. And I can even graph that here if I want to, just to show it. There it is. But let's go ahead and put the new function here. And this time I'm not going to spend so much time thinking about each individual point and like visually showing it go left, right, up, down, all that kind of stuff. Here I'm just going to translate the points more numerically. So if you look at the different things that are changing here, we have a horizontal shift of +1. It's going to the right 1. Well, what that's going to do, that's going to change my x values. So if I look at my parent function to the new graph, this right here, these x values, going to the new x values, basically are all going to be adding 1 to it. I have this +1 because my h value is +1. I'm shifting the whole graph to the right 1. So these x values are not 0, 1, and 4 anymore. If I'm going to translate those, that's 1, 2, and 5. I'm just adding 1 to the x values. Okay. Well, now think about the y values. What's happening to the y values? I'm going to go ahead and let's erase this. Right, the y values. What are we doing from one to the other? Okay. Well, there's two things that we're doing with the y values, and that's the a and the k value. We are multiplying the y values by -2 because that's the a value. That's that dilation that's happening, and we're also adding 3 to the y value. So this a and k, the a and the k parameters are really changing the y values of the graph. The h is changing the x value of the graph. Okay, so from one y value to the next, what are we doing? Well, we'd be multiplying by -2, and then we'd be adding 3 to that. I mean, that's what the a and the k value are doing. So if we go from point to point, all right, well, look at 0. Multiply by -2 and then add 3. Well, times 2 is still 0, plus 3 is now 3. That becomes a 3. The 1, if the 1 would become times -2 is -2 plus 3 is 1. And the 2 times -2 is -4 plus 3 is -1. So now those are my new points. I'm still following my a, h, and k values, but I can sort of take those numbers and really just focus more on the numbers using the h value to change the x values, and then using the a and the k values to change the y's. And so now I have these 3 points, and here are my new 3 points. So 1, 3, that's right here, 2, 1, and 5, -1. There it is. So this is my new graph. It's opening downward like this. Whereas my parent function, the normal function, just kind of looks like that, which we're not obviously graphing here. We're looking at the blue function, and that starts at 1, 3 and opens down. So there's my graph. Now what's the domain? The domain of this thing, as we talked about before, take a look at the domain. The domain is the radicand x minus 1. That has to be greater than or equal to 0 always. So therefore, x has to be greater than or equal to 1. My domain is greater than or equal to 1. And you can also just look at the graph now. Look at the graph and look at the table. You can see that the x values do the exact same thing. The range is which y values we're graphing. So the range in this case is f of x, and the y values are decreasing. You can see this blue line is going down, so the range is going to be less than or equal to, and the highest y value that we have, or where we started, was at 3. In other words, the k value. So my f of x is less than or equal to 3 for my range. And again, if you need to check your answers here, go back to your graphing calculator. You could check it on Desmos as well. But you can see, of course, the calculator is going to give you all the x values that you can plug in. You can see if it tries to plug in 0, there's an error, because 0 is not part of the domain. But the ones that we focused on, 1 goes to 3, 2 goes to 1, and 5 goes to -1. That's all the same that we got, right? 1 goes to 3, 2 goes to 1, 5 goes to -1. Those are 3 key points that we're trying to show. So there's the graph.